Okay. So today we will learn objects and classes, and then we will learn some grammars, access control. We also want to learn something related to constructor and destructor. So before this, I want to explain something because some students or many students want to learn CPP 17 grammar, the new grammar. So we will teach C++ 17 in this class. Also, because of that, we also want to switch our reference book to the CPP. This one. We also want to switch our major reference book to this one because we are learning this new grammar. Actually, the new grammar are not so much. So the key ideas are similar to the Thinking in CPP book. So if you have time, you can still read the book, Thinking in CPP. Okay, and this one is also suggested to you if you want to learn more about CPP 17. But anyways, in our class, we will use CPP 17 to keep us up to date. Okay. Also, because of that, we have uploaded some manual for you if you want to install an upper level compiler. So actually, I think this G++9 should be fine, and this is the latest one. So I think I would like to suggest you to install this one. But anyways, this G++7 version also supports CPP 17 grammar. Okay, so it's up to you. You can install this latest one. You can also install this one. And there are some commands. If you install both, there are some commands to switch between them. You can install different versions of a compiler on your Ubuntu system, and then you can switch between them by these commands. Okay, and also there may be some problem with your memory setting and the disk setting, because originally the virtual machine was assigned only a 10 gigabyte hard disk. That may not be enough. So we have some menu for you to enlarge your hard disk and memory. Okay. So this is the manual we have uploaded onto our Tsinghua Web Learning. So if you, I suggest you to download it and install the compilers by yourself. We also have some remote system for you. If you want to use that, you can contact TA and me. We can set up accounts for you. So currently we have a Ubuntu system in our lab, and this system can be remotely logged in from your side. If you want to use that, please contact me or contact TA, okay? So that's all I want to say before the class. Okay. Now I want to close the split screen message. So now we will learn this objects and classes. Actually, we can find real-world objects everywhere: a person, a bird, a car. How to describe such an object? So we can see that there are static properties and dynamic properties. So for static properties, it refers to attributes and status, right? And for dynamic properties, refers to behavior and functions. So that's how we describe an object. So an object is an entity with a set of attributes and behaviors. So in the real world, a class, so actually we can classify everything, right? We are classifying the universe. There are stars, there are planets, and then in the Earth, we have human beings, we have animals, we have plants, vegetables, everything, right? So we are making classes everywhere, right? So in the real world, a class is a set of objects with the same attributes and behaviors, right? Then in the programming world, actually, we have the corresponding class, right? This is what we are learning here, right? So in the programming world, a class encapsulates variables and functions into a structure called a class. There are some key features for this object-oriented programming. First one is abstraction, and the second one is encapsulation. So we will learn this today. And inheritance and polymorphism, we will learn this in later classes. Okay. So for abstraction, I think this is mainly the idea, right? So when we are faced with some programming problems, we first extract some common attributes or behaviors from the objects, right? By attributes and status abstraction, we get variables. And by behavior and functions abstraction, we get functions. So for example, we can define a class named bird. You know, there are many different types of birds, right, in this world. So, but most birds can fly, right? So they have some function abstraction. They can fly, they can sing, and they can eat, right? And also they have some, maybe some different colors, different height, different weight, and different names, right? So here is an example how we define a class, bird. So we can see here, this class actually have some member functions we will learn later, and member variables. These are attributes, and these are behaviors, right? These are, these are behaviors, and these are attributes, right? And these are the variables, and these are the functions, okay? So for this class bird, we may have different objects, and there are different instances of the class. So for example, we may have a pigeon, and we may have a pigeon, or we may have an eagle, right? And they are different, right? And they have different attributes and maybe same behavior, right? They can fly, and they can sing, they can eat, right? And we will learn later, if they have different behavior, what should I do, or what should we do, right? But currently, for a class, we have to have the same behavior, right? Because we have, for a class, we only have one copy of the function, right? But for variables, we can have different values. So that's a little different between functions and variables, okay? So this is how we define class. So these are member functions, member variables. We just mentioned that because we have asked you to preview and to learn the book beforehand. So I assume that most of you already know this. These are member functions, member class, and member variables. It's not so difficult. then we come to this access control. So here, we can see here, we have some suggestions for you. We have some suggestions for you. So a common convention is to use uppercase name for class name. So this is uppercase, right? This is kind of depends on the Google coding style. After this class, I will ask all of you to learn this Google coding style. I hope our students in this class will do your coding based on Google coding style. Or if you have your own very good coding style, it's fine. But because our homeworks will be reviewed by others, your coding style should not be too weird or too strange, so that others will also think your coding style is good. Okay, otherwise your coding style may not be favorable. Okay, so I hope most of you will use this Google coding style because this is good coding style, I think. Okay, and for access control, these are access control. We have public and private. Public and private. Okay. For the access control to class members, we have two sides actually. One side is within a member function. You can freely access all the member variables and member functions of the same class within the member function. That means access control does not affect class designers, right? Because you are the, for example, if you are the class designer, you are writing the class, for sure, or certainly, you should be able to access all the members, right? So from the designer side, you are free to access all the members in the class. Access control have no effect. Okay, then with a class object, you can only access public members. So this will control class users, right? For example, if you are the class user, you will use the class, for example, class name, and then define an object. Then you use the class name or the object name to access the member variable or member function. Then these member variables and member functions should be public, right? Should be public. Otherwise, you cannot access those members. Okay, then this access control is to control class users. Okay, and this is key. This is key. Access control is to control class users. So remember that. Right? If you are defining a member function, then no worry about the access control of the same class. Okay. Then more detail on public members. So the keyword is public. Then public members are accessible outside the class and accessible by the class users. And the public member functions are interfaces between class designers and class users, right? Because when you design the class, you make some members public so that class designers can access, right? And for others that you don't want the users to access, you make them private. Okay, then here is some grammar. By default, if you define a class, the access control is private because in class, we want more safety, right? But by default, access control for struct is public. So I assume some of you or most of you know this struct. So Okay, I assume most of you know this struct. But this struct, actually, we learned that. We learned the history of C language. We have the C programming language. And then we have CPP. So in C programming language, there's already struct. Okay, there's already struct. The struct is already in C. Okay, then in struct, in C programming language, in struct, we only have data members. Okay, we only have data members. So now in CPP, we have classes and we can put functions into this struct. Okay, I think that's why we have this plus, right? Because we plus class. So in this class, we can put functions. Originally in struct, we can only put data members, member variables, right? Okay. Then another plus, the first plus is with classes, plus class. The second one, second plus, I think is template. We will learn template later, okay? Then for private, we have learned that private members are only accessible in member functions of the same class. That means only accessible to the class designers, right? So this enables information hiding. We will learn this later, okay? For protected members, it's similar to private actually, but something is different when we learn inheritance. We will learn this later, okay? And then for the member functions is declared in the class definition and defined outside the class definition. It's typically defined outside class definition with a scope resolution operator. We will learn this later. We have examples. And then we mentioned something about inline functions because there are some grammar related to inline functions here. So functions with less than 10 lines are typically declared as inline functions to improve efficiency. Why can it improve efficiency? For example, if we have a class foo, these are the, sorry, this is function foo. And then we here, there's the main entrance. And we call this class, call this function foo, like this. When we execute the code, we will first, by calling this function foo, we will first store some variables, local variables here. And then execution flow will go to this function body, okay? Then after returning from this function, we have to reload or restore the local variables here. And then we execute again. So this is overhead of the function call, okay? So if we have many different, many small functions that are called many times, then that causes a lot of overhead for function call, okay? So inline function means the compiler do something to copy the code here, instead of the function call. In this way, the function call overhead is eliminated, okay? So this is inline function. However, if the inline function is too complicated, the compiler cannot do that. You will know this when we learn compiler class in the future, okay? If this, for example, if the small function contains loops or recursive functions, it's not possible to make it inline, okay? So if you use the inline keyword to make the function inline, compiler may not be able to do that, but the compiler will try to do that, okay? So this is inline function. Then class member functions can be declared as inline. Grammar is, so member functions with function body defined inside class definition are default to be inline. Okay, so this is grammar. So if you define the class and then you define the member function, then you define the body, function body of the member function inside the class, then it is default to be inline. Okay, then this is grammar related to inline functions. Actually, in Google coding style, there's also something related to inline function. There are more detailed rules for us to set inline functions. Which kind of inline functions? Which kind of functions should us set it as inline? Okay, there are more detailed rules for setting inline functions in Google coding style. Okay. Okay, now we have some questions, some example. So here we are defining a header file, a bird, and this is preprocessor directive we have learned before. And then this is class bird. We have public interfaces or public member functions. We just learned that if we define the function body within the class definition, this is class definition, right? If we define the function body within the class definition, then it is default to be inline, right? There are inline functions, okay? Inline functions. No function call overhead. That means faster, okay? But they have to be simple enough, right? Otherwise, compiler cannot do that, okay? And this is source file of the corresponding to the class definition. So member functions can be defined either in the header file or in the source file, like this, with this scope resolution operator. If we define them in the header file, we just mentioned that if we define them in the header file, then it will be default to inline, okay? But typically, we will define the function body in the CPP file, okay? So this is the main source file. So let's check the demo. Okay. Some students asked, I think I will open the bullet screen message. If you have some questions, you can ask now. Some students asked why the VI editor is different from mine to yours. That is because I have made some changes. There are many VI plugins for VI. And also there is a setting. There is a setting VM, it is called .vmrc. Right. We just mentioned that if you want to set a function inline, you just put inline here. Actually, because in classes, we don't need to do that because we have the grammar. Because we have the grammar like this. We define the function body within the class, so it will be default to inline. Okay. We will learn inline functions later again, once again. Okay. So this is a class bird. This is a class bird. And actually, inline functions are typically defined in the header file. We will learn this later because inline functions, if you define inline functions in the source file, there may be some problem if you want to use it in different source files. Okay. Okay, then if you want to customize your own VIM, then you can set it by yourself. And you can search something related to VIM. You can install some plugins so that it can be used easier. Okay, and this is a program, and we will run the program now. Actually, I also will provide you with a more complicated makefile. This will make you easier to compile different sources into a single target. Okay, if you have some interest, you can learn more about it. Otherwise, I think you can just use it. Okay. So by make explain, you can know here user sources are this, and user objects are like this. Target is like this. I know that the .exe is not necessary for us in the Ubuntu. Okay, .exe is for Windows. Okay. Now we make. So using this option, we are using CPP 17 grammar. Okay. Then you run it, test run, then you can run it. Actually, I can also run it in this way. This is because I have set the path variable. I have set path variable. In this path variable, you can see here, I set the current directory and the path. So that means when I run this test run program, the system will search this command in current directory. If you do not set this parameter, this environment variable path, there's no way to run it in this way. Okay. If you want to learn more about how to set the environmental variable path, you may need to learn something related to this one. So in your home directory, there is a hidden file named .bshrc. So in this file, you can set some variables. You can set some variables like actually there are different variables to customize. There's a path. Okay. Maybe we'll learn LD library path later. Okay. And this is the example for this class bird. Now we'll learn encapsulation. So we just learned the example of this class bird. So encapsulation is based on access control. Okay, because we integrate attribute and behavior into an entity, then we can improve safety by access control. Okay, then class users can only access public members. We have learned that, right? So in this way, by access control, we can decouple between class users and class designers. Okay. For example, if you are the class designer, you may design a class A, right? Then in class A, you may have some variables like that, some variables. Then you may have some functions like this, right? Then for this function, you may put you may make it public, right? Then for class users, they can use it like this, right? Then maybe in the future, you found that this implementation of this for this function 4, you may want to have a better algorithm, right? Or you may even change these different variables to make it more efficient. Then if you want to change the implementation, you do not need to worry about the usage, right? Because you only expose the public interface to the class user. Then, as long as you keep the interface the same, no worry about the class users, right? You just re-implement this function body. That's fine. So this decouples between class users and class designers. Okay, let's have 5 minutes break. If you have any questions, you can still ask questions by bullet screen message.大家如果有问题的话，现在也可以提问啊，可以通过这个弹幕来提问啊。For in-class presentation, I think from next class, I may randomly assign some students to give in-class presentation. For now, for this class, we will learn more class contents so that we may have more time in the future to give in-class talks. Because without learning the class, we may have little to share in the in-class presentation. So maybe starting from next class, or even starting from the next class, we may start in class presentation. 就是我们这个课堂报告啊，就是也不一定是下节课啊，也可能是下节课。我们会把这个课程内容尽量往前提，然后呢，更多的时间呢，后面来做报告。这样的话，我们学了课程内容之后呢，才有更多的这个问题来 share， 或者是学了更多的东西来做课堂报告。课堂报告的内容，the topic 已经在网络学堂公布了，咱们可以到网络学堂去看一下。The topics of the presentation have already been uploaded in our Tsinghua Web Learning, so please check the topics in our Tsinghua Web Learning for the in-class presentation. Currently, I think if you want to present earlier, you can send me an email. Yes, I will guarantee that the presenter will know that beforehand, at least 5 days beforehand, I think, or 1 week. Okay. For the in-class presentation, there are 8 minutes. 8 minutes, 8分钟做课堂报告。然后我们会给大家留大概1个礼拜的时间啊，咱们可以现在就开始准备 in-class presentation 啊。So you can prepare your in-class presentation now, but we still will let you know beforehand, at least I think 1 week for you to prepare. Okay. Okay. Now we learn struct versus class. So we just learned that in the struct was already introduced in C programming language, right? So in CVP language, the language inventor just he wants to use some new keyword, so he introduced this class for this special structure. Okay. So access controls are different for struct and the class. For by default, the struct has access control of public, and by default for class, it is private. Now we will learn this pointer. So this pointer points to the address of current object. So different objects of one class have different addresses and different these pointers. Typically, this pointer is used in function overloading, it's operator overloading. We will learn this later. For example, for the equal assignment, we will need this operator overloading, and we will need this pointer to return current object. Okay, because actually let's learn it later. Okay, so anyways, we will learn this pointer now, and we will learn operator overloading later. Okay, so this is an example of this pointer. So for the original bird class, we can return this pointer because this pointer points to the address of current object. So actually it points to bird star, right? It's pointer to bird type. So in this way, because we can get the current object, so we can do it in this way, right? By set name, and then the pointer to the product is the pointer to the object is returned, then we can call another function like this. Okay, then we will have one more demo. So in this demo, we can see so in this demo, we can see that in the header file, we have returned this pointer, and also we have printed the address of this pointer. We use the static cast to cast this pointer into an address. So this is the grammar for casting a pointer to the address so that we can print it by cout. Okay. Then in the main program, we first set name and then set speed. This is for eagle. And the second one is for pigeon. You can see here, we first set name, then this set name function returns the pointer to the object. Then we use the pointer to access the other function, a member function. Okay, and test run. You can see here, first one is eagle, right? Because we call the set name function. So address is printed. Second one is pigeon, right? You can see here, the two objects have similar address, but the lower address are different, right? Lower address are different. So these are the addresses of the objects, okay? So for summary, for this class, for this slide, actually, we have learned objects and classes, access control, abstraction and encapsulation, right? I think abstraction and encapsulation are two key OOP features we need to know, right? And also this pointer. For this class, we have some homeworks for you to finish. And before finishing your homework, I suggest you to study the Google CPP coding style. Here is the link to the. Our students are required to finish coding in homeworks in a good coding style. So this Google coding style is suggested to you. And if you really have a good reason not to use this Google coding style, and then I think you really need some reason, okay? Otherwise, if your programming style is not accepted by others, maybe it may affect your homework credits, because other students will evaluate your homework after you finish it, okay? Anyways, I suggest you from now on to, if you write some code, stick to your own coding style. I hope you have a very good coding style, okay? And then I also suggest you to review what we have learned and read this book. And also, we may not have time to learn in detail friend and nested structures. I hope you to learn it by yourself, okay? Then this is for lecture 2. Now we learn lecture 3. So in lecture 3, we mainly learn constructor and destructor. Here is a question. Here's a question. What is the scope of object A? So we can see here, if you want to know the scope of the object, you first need to know where it is defined, right? We can see here, Okay, it is get birth here, right? Get birth here. It's created here. So the scope of this object is this curly brace, right? So this object will die here, right? Will die here. Outside this scope, we cannot access it, right? So this is the scope, or this is the lifetime of this object A. Okay, then when we know this, we may define a class like this. These are the member variables, and we have some public interface. Here's one question: how to initialize the values for these member variables, and how to clean up the variables when it's going to die. Originally, if we do not have constructor and destructor, and that's what we are learning today, if we, in the language, if there are no constructor and destructor, we may need some functions, right? Like this. This is init and also cleanup. So when we define this object, we have to use the init member function to initialize the variables, right? And then before it is going to die, we need to clean up the resources occupied by the variables. So this may be how we use this init, and this is how we clean up. Actually, we use the new and delete. Actually, in CPP 17, unique PTR is suggested. So using this unique PTR is better for us to avoid memory leaks. What the memory leak means, we just allocated memory and used it, but we forgot or we forget to clean up. For example, here, if we forget to delete, then this memory will not be freed. It will be loosed, and it will leak to the it will leak to the system. The system will never find this memory again because we did not clean up the memory. Okay, so this is very important. We need to delete it. But if we use unique PTR, the unique pointer will help us to clean up automatically. We don't need to do it by ourselves. Okay. Anyways, we need to know new and delete because there are many programs written in this new and delete. Many programmers don't use unique PTR. So we still need to know new and delete in case we are reading or we are using other one's code. Okay. So for this implementation, any problems for this? The problem is that a careless user may forget about this, right? A careless user may forget to clean up, or a careless user may forget to init. So a better solution is to use constructor and destructor. And then for this constructor and destructor are introduced for better safety, right? There are special member functions for initialization and cleanup. Important thing is that constructor and destructor are called automatically. This is important. Automatically called. You don't need to worry about that when an object is being created or deleted. So this guarantees that the initialization and cleanup will always be caught or executed. So this avoids the careless users, the errors caused by careless users, right? So constructor and destructor are typically public. Otherwise, there may be compiling errors. So we just mentioned that constructor is for better safety, and it guarantees that member variables be initialized before usage because it is automatically called. Okay, then here is an example. So when we define an object like this, or when we use new to define a pointer to the object like this, then we are defining new objects. Then constructors are automatically called. Okay, here's the stack and heap object. We will learn it later. Okay, and this is a way to define stack objects, and this is a way to define heap object. Use new. So the constructor is defined as like this. Constructor's name is the same as the class name, like this. And there's no return type. Right. So actually, this name is the same as the class name. Actually, it's not necessary, right? I mean, in other languages like Python, the constructor is like this. So this is constructor for Python class. So it's not necessary to have this name, but anyways, in CPP language, the constructor needs to look like this. Okay, so there's always a way. If you are designing the compiler, you are to determine, right, which kind of constructor name you want to use. Okay, the typical rule is to avoid conflicts with ordinary names or ordinary members. Right? So by introducing this constructor, object definition and initialization are unified. So whenever you define a new object, it is automatically initialized, right, by this implicit call of the constructor. So now a good CPP programming style is to initialize whenever you define variables. So this is the grammar for, I think, for CPP 17 to define a variable and initialize it. And this one is for defining an object, but you need to define the constructor to automatically initialize the members. Okay. Okay, then default constructor. Default constructor is a special constructor without function arguments. For example, it's like this. Let's select this. There's no function arguments for this constructor. Then this is a default constructor. Okay, then default constructor, we just remember it. No arguments, then it is default constructor. Okay. So default constructor have many usages, or it's very important. For example, if you want to define an array of objects with 1,000 objects in the array, you can only use default constructor, right? If you define it in this way, you can only use default constructor like this. Okay. Then there are also other ways to use default constructor like this. If you define an object without parameters, Actually, for this one, should be like this, right? In CPP 11, sorry, CPP 17, right? You should use this grammar, not this, okay? Because in this grammar, we use this, the parentheses may conflict with functions. So because function calls this is good question. If we define an array of 1,000 objects, I think it will be the constructor will be called 1,000 times. I think so. But you can do some tests. For example, in your constructor, if you define a default constructor, you can print a message, right? You can print a message in your default constructor. Then when you define this array, if the constructor is called 1,000 times, then you can print the message will be printed 1,000 times. Am I clear? So you can define, you can print something within the constructor. Then if it is called 1,000 times, there will be 1,000 lines of the printed message. Okay, you can check it. Okay, I think so. I think so. The constructor will be called 1,000 times. Okay, then this grammar is better because in this way there's no confusion between function calls and the object creation. Okay, when no constructor is defined in the class, compiler will synthesize one. So this synthesized constructor is called a default constructor. And because the synthesized default constructor has no arguments, so it is also called a default constructor. Am I clear? Because there's no constructor, so the compiler synthesizes one, so there's one default. Another default is for no arguments. Because there are no arguments, so it's also called a default constructor. So this is called a default constructor synthesized by the compiler. Okay. This grammar is that if a constructor is already defined, compiler will not generate the default one. So a good programming style is to avoid the default constructor. Always write your own default constructor. Okay. In this way, you control everything. Don't depend on the compiler to do something. Otherwise, there may be some tricky bugs or pitfalls, difficult to find. Okay. Then here is an example. Is default constructor. You can see here. Actually, this is another grammar. It's in-class initializer. This can be used with the default constructor, because the default constructor generated by the compiler has nothing, no arguments, no function body, nothing, nothing inside. So the compiler generated the compiler generated constructor do nothing, right? Just to guarantee that there is a constructor, so that an object can be created. But if we have this in-class initializer like this, then when the constructor is called, object will be initialized in this way. Okay, so the default constructor is can be combined with the in-class initializer, so that the variables can be initialized. Okay, we have an small demo. You can see here, this is in-class initializer. actually the default constructor, if we do not define any constructor, then the default constructor will be synthesized. Okay, so we only have a member function here, no constructor here. Okay. Then in the main function, we define an object with the default constructor. Then we print the volume. Okay. Then because the initializer is like this, so the volume should be the product of these numbers, right? Let's check. Actually, we don't need that. Just run it in this way. So this volume is 12, is the product. Okay, and this is the default constructor and in-class initializer. Now we have another example. You can see here we have class tree and we have one member variable and in-class initializer. And we have two constructors like this. Question is which constructor is called? For the first one is default constructor. Second one is this one parameter constructor. And third one is interesting, right? Because we have something, some parentheses here, right? Let's check later. The third one, we know that this is a grammar, CPP 17, right? This default one is called. How about this one? This one with parentheses. Let's check. So you can see here, we have okay, we have this tree. You can see here, we have the member variable, and we have two versions of the constructors, and we have member function. Then in main, we define the objects in this way. Let's check. We just saw that it compiled correctly. Compile correctly. Then now, sorry. Now we can see test run, get nothing, right? Get nothing because we did not print anything. Maybe you think it is correct, right? It is correct because no compiling error, no runtime error. It's correct. But we can open this. We can call this member function to check. Right? So if we open the member function, we can see here, tree3 cannot call the member function. Tree3 cannot call the member function. Interesting, right? So it mentioned the no class type. The tree3 is not a class type. Interesting. Why tree3 is not class type? So compiler may regard it as function declaration, right? because function declaration is also look like this. So compiler regards this as a function declaration, not the object creation or object definition. Okay. So this one is error, right? We cannot define objects in this way. Okay. Now, which constructor is called for this? So we have class tree, and there's one constructor defined, no default constructor. So which constructor is called? So we just learned that if we define a constructor, no matter what kind of constructor it is, compiler will not generate the default one. So for this case, no default constructor. So in this way, this one gets error, right? This gets error, sorry. This gets error and this gets error because there's no default constructor, because we have already defined one. Compiler will not help us to generate anyone, right? Then these two are wrong, right? These two are wrong, okay? And this is grammar. Another one is the using default keyword for default constructor. So this is very simple, I think, very easy to understand. So typically, if you want to define a default constructor, but actually you want to do nothing, then you just use default keyword. And no need to type the function body. Okay. And now here is the member initializer list. Okay, that's a good question. I suggest you to try it in your own compiler. Okay. So I think I forgot to mention that I really suggest you to play with compiler. I always play with compiler. Then you can know many different things related to compiler, right? Because sometimes compiler will behave differently, right? So I really want you to play with compiler for different cases, different anything you can think of. You can try it in your compiler. Then, if you really cannot get the answer why the compiler behave like that, you can come to me or come to our TA for discussion. So, for example, you have some program, and you compile it and run it, but you don't know why the compiling information is like that, or why there is a compiling error, or why it runs like that. Then you can come to me or come to our TA to discuss it. Otherwise, if you have some interesting idea, I suggest you to try it in your compiler, okay? Play with compiler, that's really needed for you to practice and learn this language, okay? Then the member initializer, this is another grammar. So this way, this is one way to define this constructor, and this is another way. Right? So you have a semicolon, then you can initialize the members in this way. Then you have a function body. So this is the grammar of the member initializer list. So this member initializer list is used in many different ways or many different places. For example, we will learn const and static and other grammars, const, static, and inheritance, composition. All this depends on this member initializer list. So this grammar is important because it relates to many different topics. Okay, so for this grammar, another another thing that I want to say is better efficiency. Okay, if we use the constructor 2, if we use constructor 2, because they are initialized in the function body, so the variables, member variables, are first created and then assigned to a value. So there are 2 operations. But if you use member initializer list, there's only 1 operation. You initialize it and at the same time assign it a value. Then it has better efficiency. Okay, so better efficiency is guaranteed for member initializer list. Okay, so you are suggested to use member initializer list. Okay. Another one is explicit. For this explicit is for single parameter constructor. So for a single parameter constructor like this, you have a single parameter here, then it can be used as conversion, can be used for conversion. For example, if you define a function, like this, then you call it in this way. You put an integer here. Then, because the constructor takes an integer parameter, so the constructor will be used for implicit conversion from the integer to an object. So it works. Interesting, right? So, but sometimes you may not want that. Maybe this is typo. The user carelessly use this function. Maybe he does not want to use it like that. Then you need to put the keyword here. By putting the keyword here, this implicit conversion is forbidden. Then this function call, you'll get some companion error. Okay. Okay, then now you can see here, there is 1 parameter constructor. Actually, there's also another 2 parameter constructor, but this does not count actually. So we only focus on this 1 parameter constructor, and it is not explicit. Okay, it's not explicit. And now we use it like this. We have this foo here. Then we call it this way. Then we just saw that it compiles well. Then we run it. Runs well, right? Then if we open this explicit keyword, maybe X, add it here. Sorry, we should add it here, right? Sorry. Then we can make it. Okay. Then we can see here, because it is explicit, we cannot do this implicit conversion. We cannot convert from int to tree anymore. Cannot do that. Okay. So this is the usage of this implicit conversion. Okay. Next one is delegating constructor. This is very simple, I think. You just in the constructor definition, you just call another constructor to initialize part of the variables. Then you can do other things in the function body. So this is using this constructor to delegate this constructor. Right? So this very simple grammar, I think. Okay, and this is constructor. And now we will learn something related to this structure. So for this structure, cleanup is very important. We know that also the this structure is also called prepare to die member function, because the object is going to die and we need to clean up the resources occupied by the object. So this structure is automatically called by the compiler. So it's called like this when an object goes out of the scope or when we use delete. So we also mentioned that we should use unique PTR or shared PTR instead of new and delete in our class. But we still need to learn, we need to know new and delete, because others are still using new and delete in their programs, okay? And the explicit call of this structure is not suggested, okay? We still have a one more demo. So this unique PTR, I think the usage is very simple. We just have a quick look on the usage. You can see here, this unique PTR is used like this. So you define unique PTR, and then this is a type. You define a pointer to this type. This is an object. This is a pointer name. Then you use this. You can new the object in this way, right? In this way, you have a unique PTR. Then you don't need to clean up the memory taken by this. So because the unique PTR will automatically free the resources for you, okay? And you need to add some header file like this. Then you can use it, okay? So this is a unique PTR. So this is a destructor. I think it's very simple. I'll not go into detail. So when you free member variables allocated on heap, the other occupied resources, then you may need to define this. You need to define function body of the destructor. Default destructor is very simple. It's similar to default keyword used for constructor. So you just, because if you do not want to do anything, you just use default. You do not need to define the function body. Okay, then there's stack and heap. So stack and heap are the memory fragments for storing the variables of the program. For stack, it has a limited size of kilobytes or megabytes, depends on system and compiler settings. It stores local variables and different functions. So these are the examples. If we define some variables in this way, then these variables are stored on the stack. Then because it has limited size, so there may be stack overflow. If we, for example, if we define a very large array, or if we have very deep recursive functions, then the stack may overflow because there are many local variables. These local variables are stored in stack, but it has limited size, so it has overflow. Memory is used up. Good thing for stack is that you don't need to clean up the memory. When the object goes out of the scope, it will be cleaned up. And also stack variables runs faster than heap variables, okay? Then for heap variables, the size of the heap is much larger than the stack. So large arrays or large variables, large objects can always be allocated on heap. So these are the ways how to define heap variables using new or malloc. This is a C function actually. Malloc is C function to allocate memory on the heap. So in this way, we are defining arrays on heap. So these variables are very large, and also we need to delete. Otherwise, this memory will be leaked into the system. So that's called memory leaks. Okay, and this is stack and heap. Maybe if you have some interest, you can look deeper into it and make some in-class presentation on stack and heap. Okay, and there's some comparison between constructor and destructor, and then this is easy to understand. And then we have some example here. So for this example, we have the quick demo. So we have a tree defined like this. There are some member functions and the constructors, and then there are some member functions defined. And then in main, we have this. Right? We have this. So due to the time limit, we may not have time to explain more in this, but this is automatic call of the constructor and destructor when it goes out of the scope. So this is the print version, okay? Printed message. Okay. Then we have some new ways to define the objects. So the good programming style is to use to define variables as close as the point of use as possible. Right? So this is actually not so difficult to understand. Then we have some questions for you to practice. And now for next class, we will learn the overloaded functions because we have different versions of the constructors with the same name. So this is overloaded function for next class, okay? Okay, then this is all for today's class. Thanks very much. Bye-bye.